This next session will focus on one of the four foci that the organizing committee decided on. So just to briefly give you an outline of what to expect for more or less the rest of the day. So we've broken up this topic of promoting convergence research into four major areas. One, key organizational structures and needs. Second, faculty development. Third, education and training. And fourth, interinstitutional partnerships. Perhaps I should introduce myself. My name is Tim Galitsky. I'm the head of science and technology at EMD Millipore Corporation. I'm also an affiliate professor at the Institute for Systems Biology, where I was a professor for the first 10 years of that institution. So in this first session, what we want to do is we want to talk about key policies, procedures, support structures, also cultural dimensions of supporting convergence research, and also infrastructural considerations, technology, physical space, etc. And so we've put together a panel of speakers, and to kick things off, we have Terry Murray, who is the Dean of the Harvard University School of Engineering and Applied Sciences.
Thank you. In the next really 5 minutes, because I want to listen to the panel, I'm going to summarize a report a member of the committee, I was a member of the committee, and it's a report out of the American Academy of Arts and Sciences, and it was sponsored by a number of foundations, Bechtel, Lounsbury, Research Corporation for Science Advancement, thank you, Jim, Michael and Susan Dell Foundation, Gordon and Betty Moore Foundation, and the Hellman Foundation. And this was a committee. Here's the report. It's on the American Academy's website. This was a committee that was formed after the 2008 report, ARISE 1, which was looking at the health of the research enterprise in the U.S. in particular. And so it had no goal except to look at what could be done to encourage the health of the research enterprise given the ARISE 1 report. The ARISE 1 report in 2008 basically said we really need to focus on the funding of young people and young people getting into science and engineering. It had an incredible effect. Maybe it was just the timing, but because of that report coming out at the same time legislation was coming out and budgets were coming out, some enhancements in Young Career Awards happened. So we're hoping, and you'll see that this is very well timed with this conference, that in 2013 this report came out. The committee was a very large committee, and you can see some of the members are in the audience. It was chaired by Zenki Narayanamurti and Keith Yamamoto, and the committee converged, amazingly enough, on convergence. So we started thinking about research being at an inflection point. From ultra-specialization and defined problems in, say, the 1700s, 1800s, as disciplines were being formed, which everyone is pointing out is still important today, to all-hands systems approaches and major complex problems which we are facing today, and Phil actually listed a number of them, like how are we going to feed 9 billion people in the world sustainably, a very challenging problem. And so we decided, the committee decided, it's time to reassess and revise practices and policies. So what we came up with, and this is possibly why it was deemed relevant that I bring up this cultural difference. Historically, the physical sciences and engineering is a little bit different from the life sciences and medicine. So the physical sciences and engineering means physical sciences and its applications as through engineering, and the life sciences and its applications through medicine. These were the two ecosystems that we looked at. Because of after and during World War II, the Manhattan Project, the Apollo Project, putting very specific and very important goals in front of the physical sciences and engineering community, there has been, and coupling that with the very large research and development organizations that developed the IT, semiconductor industry, materials industry, computer industry, where there were very large research labs, Bell Labs, Xerox, IBM, RCA, et cetera. There has been more of a continuum of discovery and application in physical science and engineering. Not completely the case at all research universities, but way more so than there has been in life sciences. And in fact, interestingly, if you look at the applications, the company spin-outs, et cetera, that spun out in life sciences, the genomics revolution, et cetera, they have typically been initiated by physical scientists, chemical engineering, physics, in the radiation therapy, et cetera, and not by the pure biologists. This has to change, and it is changing. But there is a different culture, and I actually noticed that at Harvard. Since my background is I was at Bell Labs for 27 years and ended up being a senior vice president, so doing research and technology development in the telecommunications industry, and then went to Lawrence Livermore National Lab as deputy director for science and technology, where there are major, mostly physical science and engineering projects. But when I listened to my colleagues who are in the pure biology at Harvard, I noticed a difference between the we do pure research versus this research could be of great import. It might be 20 years from now, but it's really important. So focusing on the importance has been mostly, and you will hear about this when Don Ingber talks, the clinical faculty, not the pure biologists. But we need the pure biologists. We need to understand biology. So there are common drivers of change. There are new opportunities where we actually need convergence, and there are also political and economic forces. So we found two goals. One of them is to integrate practices and policies across one plane, which is transdisciplinary science, so that is your convergence. Extremely important, that's why we're having this conference. But the other is to integrate across stakeholders. So we actually need cooperation across academia, industry, and government sectors, as well as foundations and non-government. Because things are rather complex and the funding landscape is not the same as it used to be when there were major research organizations in the physical sciences industry, let me just say, for the health of the nation and actually for life sciences and making breakthroughs in medicine, we need to have more partnerships, and they're on two planes. So that if you want to take one thing from this talk, that is, yes, transdisciplinary research is really important, but you can't do it without another 90-degree partnership. So goal 1 is to move from interdisciplinary to transdisciplinary, and that doesn't mean everyone, but a certain amount, I will say 20% at least, of the research enterprise should be focused on this. And goal 2 is to promote cooperative, synergistic interactions. And one of those, I would say, since I'm going to stop here and not go through the very detailed list, which you can find in the report, is the technology moves and technology transfer moves with 2 feet, not licensing agreements. I completely agree with that. So let me stop and we'll get on with our panel.